Right, this video is on chemical bonding and the differences in the two types of bonds that we'll be talking about, which are ionic and covalent. Okay, so the first topic is, why do atoms bond? So meaning, how come in our world we don't just have a bunch of single atoms of all the elements, but how come they get together in ratios with other elements to form compounds? Okay, and this is actually something that we've already discussed, and it's because all atoms want 8 valence electrons to fill their energy level, their outer energy level, I guess I should say. And thus to become stable. So that's an old piece of information. We talked about that when we talked about the octet rule and ion formation and the gain and loss of electrons and formation of ions. But this is the why to chemical bonding. Okay, atoms bond so that they can acquire 8 valence electrons and then become stable. And they're going to do this in 2 ways that we're going to focus on. So the first way is by the gain or loss of electrons. And this type of bonding is ionic bonding, which we'll talk in more detail about in a minute. And the second way, which would be the new piece of information that they can do this, is by sharing electrons. And this type of bonding is called covalent bonding. Okay, so these are the 2 main types, and we'll look at who bonds ionically and covalently, and we'll also look at an ionic bond example, or actually several, and a covalent bond example. Okay, so now the discussion of who bonds ionically versus covalently. So the word ionic, of course, has a root word, which is ion, and so it shouldn't come as a surprise to you that ionic bonds are going to involve ions. But kind of a more specific definition is that ionic bonds occur between a metal and a nonmetal. So if you remember from your periodic table, we know that metals lie to the left of the metalloid line and nonmetals to the right. So there's also a couple other ways we can say this other than ionic bonding occurs between a metal and a nonmetal. And we can say that metals acquire positive charges when they form ions. Nonmetals acquire negative. So we could also discuss that this ionic bond occurs between a positive ion and a negative ion. And then we know that the positive ion is called a cation, while the negative ion is called an anion. So there's pretty much 3 ways we can discuss ionic bonding in terms of who bonds ionically. And we can say it's a metal and a nonmetal. We can say it's a cation and an anion. Or we can say it's a positive ion and a negative ion. So all 3 of those descriptions fall under who bonds ionically. Covalent bonds are made up of 2 nonmetals. Which of course lie to the right of the metalloid line. So I'll just draw this real quick since we're not looking at a table. We know that the periodic table looks something like this. That metalloid line comes like something like this. Your metals are here. Your nonmetals are here, with the exception of hydrogen. Okay, so just a quick review of who is a metal and who is a nonmetal. Okay, so from here, now we're going to look at examples of ionic bonds and examples of covalent bonds. So back to ionic. Ionic is a metal and a nonmetal, and the giving and taking of electrons, or the gain and the loss of the electrons. So one of the most famous ionic compounds that exists, it's salt, and we know that its formula is NaCl. But this is a discussion of why. Okay, why is the formula NaCl? Why is it 1 sodium and 1 chlorine involved in the formation of salt? So if we think about this from a valence electron perspective, we know that sodium comes in with 1 valence electron, and I'm going to draw that as a dot. And chlorine has 7. This is old information on how to count valence electrons. We also know that the magic number of valence electrons is 8. And so chlorine is in search of one more, and sodium has one electron that it would like to give away. And so these two are a perfect pair for each other because sodium wants to give its electron to chlorine, and chlorine will gladly accept it. So then what happens is sodium lost an electron, so it becomes +1. Chlorine gained an electron, it becomes -1. And everybody has an octet of electrons. They all have 8. And because of this, it took 1 sodium and 1 chlorine to form this bond. And so we write the formula as 1 sodium, 1 chlorine. Notice there are no charges because the charges have canceled out. +1 and -1 add to 0. No charge. Okay, so that's one example of ionic bonding. I'll give you another one, which is, could the same thing happen with magnesium and oxygen? So first it has to meet the criteria of one's a metal and one's a nonmetal, and that's true. Magnesium is a metal, oxygen is a nonmetal. Magnesium comes in with 2 valence electrons, oxygen with 6. Oxygen would like to gain 2, and conveniently magnesium wants to lose 2. So magnesium gives its 2 electrons to oxygen, resulting in a magnesium ion with a charge of +2, an oxygen ion with a charge of -2, and it took 1 magnesium and 1 oxygen for this to happen. My charges add up to 0. I have 1 magnesium, 1 oxygen, and so my formula is MgO. Now, can this occur in a ratio that's not 1-to-1? And the answer is yes. So let's say we were looking at the bonding between calcium and chlorine. So calcium is a metal and has 2 valence electrons that it would like to give away. Chlorine, of course, is the nonmetal and has 7 valence electrons and would like to gain 1. So calcium, well, calcium's interested in getting rid of its 2 electrons. Chlorine only wants 1 of them. And now calcium is stuck with 1 more electron to give away. And so what we do in this case is we bring a second chlorine into the mix. Because, see, the second chlorine also comes in with 7 valence, and calcium then gives its second electron to the second chlorine. So now what has happened is we have calcium who gave away 2 electrons and has a +2 charge, chlorine who gained an electron and is -1, and chlorine who gained an electron who is -1. And if you think about this from a charge perspective, +2, -1, -1 add to 0. And that's what we want. And so when we go to write this formula, we say there's 1 calcium, but there are 2 chlorines. And so this formula looks like this. Okay, so these are 3 examples of ionic bonding. Notice in all 3 that the electrons are being given away by something and taken by something else. And that is a definition of ionic bonding, the give and the take, or the loss and the gain, or however you want to say it, or the transfer of electrons. Okay, so these are all 3 examples of ionic bonding between a metal and a nonmetal. Notice the ratio is not always the same. Right, this was 1-to-1, 1-to-1, and this was 1-to-2. We'll see some other ratios later, but this is the basics of ionic bonding. Okay, now we're going to compare that to a covalent bonding example right now. And so in covalent bonding, we have nonmetals who share their electrons. And so this is slightly different. We haven't seen this before. So I'm going to explain to you the bonding that occurs in a compound called F2. Okay, this is a real thing. And you might guess it's made up of 2 fluorines. Okay, 2 fluorine atoms. Well, each of those fluorine atoms comes in with 7 electrons. And of course the discussion is, well, who's going to give up an electron to give to the other one? Well, neither of them are. These are both fluorines who want to gain an electron, and so neither one is going to give up their electron. And so this is a completely different discussion than what we just talked about with ionic. There is no giving and there's no taking of the electrons. Instead, what these fluorines decide to do is they decide to take these 2 electrons that are right here and share them. And the way we denote that is by connecting them with a line, okay, to form the covalent bond. And how does this help the fluorines? Well, remember that the magic number is still 8 valence electrons. And so these electrons here, it's 2 electrons, and they are shared. Well, that means that each fluorine has access to both of those electrons. So this fluorine has 2, 4, 6 electrons all to itself, plus 2 more from the bond. Well, that's 8, because these ones are shared. And the second fluorine is the same thing. 2, 4, 6 electrons to itself, plus the 2 shared electrons from the bond, giving it 8. And so this is a covalent bond. Okay, as you may notice, there were no electrons given and no electrons taken. In this case, they are shared. Notice there are also no charges, right? Because no electrons were given or taken, there are no ions, there are no charges, and this is a completely different discussion than these pictures that we drew up here, right? Notice nothing's being shared in the ionic situation, and nothing's being given or taken in the covalent situation. Now, covalent bonds, we can draw pictures like this for lots of things. These are called Lewis structures, and that's actually a whole topic in chemistry that we'll get to. But this was just an overview so that you can see the difference between ionic bonding and covalent bonding.